Thank you for joining us for the training for LXP 5 kilowatt. Now I will start. So if you have any questions, you can send message in the chat. So today I will introduce 4 parts. The first is solutions. So it's like what's the hybrid where the hybrid can be used. And the next one is the features of LXP 5 kilowatt. And the third one is since once you install the LXP5 or any inverters from Luxpower, we suggest you to connect to our monitor system. So I will have a very brief introduction for the system because later I will introduce the function according to the website settings and also explain the working modes for the products. Okay, so let's go to the solutions. For the LXP 5 kilowatt hybrid, we can use in many applications. For example, we can use in a typical hybrid system. When I say typical here, we can see for the typical hybrid system, we have solar panel here, we have battery here, and we have load, we have grid. With the monitor system, you can see everything. So this is a complete hybrid system. However, in some applications, customer may buy part of them. For example, we can support off-grid, or there is no utility, or for backup. So it also can be worked with in off-grid application or backup situation. For some products in the market, you have to buy ATS or a backup box to have the hybrid, to have the off-grid function. But for the LXP5, it's already integrated in the unit. And also that it can be used in the parallel application because in some houses, the power demands is very big. So you may want to start with one inverter and later you find the power is not enough. You want to extend the system. You can add more units in your system. So it's for parallel solution and also that we can work it with generator. We call it microgrid application. For when connect to the generator, you need to enable microgrid, and also that if your generator support the remote start and the stop function, you can connect a dry contact box so it can be controlled remotely. We mentioned that this is a typical hybrid system. However, customer may from the start, they want to begin with a simple system, as simple as possible, because it's not a very cheap product. You invest some money. So our inverter is very flexible. There are many combinations. Like for some people, if they just want to buy a system for backup, because as we know that we always have load shedding in South Africa. So if he only want to use the system for backup, then he can only buy battery and the inverter. He doesn't need to buy solar panel. Only in future, if he think necessary, he can add the solar panel later. Also that for some application, but I think maybe not in South Africa. In some other countries, people may think now the battery is too expensive. I only want to have on-grid function. We want to use the solar panel to generate the power and take the load and sell to grid. So then our inverter also supports this.
Okay.
You can have the solar panel, inverter, and the grid. So without battery, the system can work very well too. Also that, as mentioned, if there is no grid, it's a completely off-grid application, then it also supports like that. And if you want to have a bigger off-grid power, you can parallel more units in the system. On the right, there are some parameters. You can see that for the PV range is a 5 kilowatt inverter, but the power can be maximum 8 kilowatt input. And also that for the battery, you don't have to connect battery at the beginning, so it's from the 0. And after a while you want to add battery, you can have maybe 5 kilowatt or 10 or 20, depends on your demands. For the monitor system, we support Wi-Fi, LAN, 4G dongle, and for default, we will ship with Wi-Fi dongle. Then for the grid connect, we can connect to the grid or running completely off grid. And also that for the certificate, you can see that since we have many certificates for all over the world. And for the South Africa, we support NRS 097. And also our inverter is in the Cape Town list. So for the 5 kilowatts, there are the features or parameters for the inverter. The first is IP165. So it supports outdoor installation, and it's natural cooling, which means that there is almost no maintenance after installation. You do not need to change fans or do some maintenance. So it's online remote monitoring. You can see everything. You do not need to go to the site. For the PV input, it has 2 MPPTs and with 8 kilowatt solar input. The transfer time is 10 milliseconds. And when there is solar, it's 5 kilowatt. It can take 5 kilowatt. When there is at night, when there is no solar, the maximum output is 4 kilowatt. Also that the unit support single phase parallel and 3-phase. You can use 3 inverters to compose a 3-phase system. For the parallel, we support like battery share, means that for all inverters, you share a big battery bank. Also that we also support separate battery groups. So for example, if you have 3 units in the system, for each inverter, you can have a separate battery group, and the battery master communicate with the inverter. So it's like separate battery strings. The benefits for that is that because when you combine many batteries together, you have to make a very big bus bar, and also that the cable may need a big cable, which is high cost. So when you connect the battery separately, when you connect the battery separately, that the connection is very easy for installer. And also that we support the microgrid function with generator, as I mentioned. You can set generate start, SOC or voltage and stop. So the generator can remotely start and stop according to the SOC. So the next one is that we have for the monitoring, if you have to see what the status. We have a LCD on the inverter. However, most of the time people prefer to use the app and the website to see everything, because we have more settings on the website. It's easy for customer to operate. So talking about our monitoring system, that the monitoring support remote upgrade and also remote settings for sure. The last one is battery communication. So the inverter has both CAN bus and the RS485 communication port. In the market, there are many battery brands, and we are compatible with most of the popular brands in the market. However, we have a compatible list. So please make sure your battery is compatible with Luxpower inverter if you want to use them as a system. In this page and the next page, I make them as group, so I can share some more details about parallel connection and battery and something else. Part of them are in the previous page, but I will have more details in this page. So let's talk about the parallel function first. For our hybrid inverter, we support 10 units paralleling now, and I can share later that the first parallel system, the biggest one we are running in South Africa is 8 units in Durban, and it's running since 2019. I visited South Africa that year and to support the first parallel installation. So later I can share you the monitoring of the system, and also that as mentioned, we support single phase parallel and 3-phase parallel. For single phase, it's very easy. It's like if you have a bigger house, you want to have large power, so you can have 2 for 10 kilowatt or 3 for 15 kilowatts. And for 3-phase parallel, it's like some always used in a small commercial situation. As I mentioned, the first parallel system in South Africa is like 8 units, and it's also running in 3-phase. The good thing for that the good thing for the parallel is that because in the house for different phase you may have different loads. So for 3-phase parallel, for each phase we can connect different numbers of the inverter. For example, if you have bigger loads in R phase, and when you are using self-consumption, you want the solar to take the load, right? Then you can install more inverters on the R phase. And if you have the less power in T phase, then you can have maybe only just one inverter. But please make sure for each phase you have to at least get one inverter in the system. So that's what I describe is actually the item 3. Support unbalanced 3-phase connection is that if, for example, if you have 15 kilowatt in R phase, 10 kilowatt in S phase, and 5 kilowatt in T phase, then you can install 3 units in R phase, 2 units in S phase, and 1 unit in T phase. So for the different phase, you can install different numbers. The next one is a flexible battery connection method. So as I mentioned, for most of the units in the market, when you are using parallel, you have to connect the battery as a big battery bank. The advantage for that is all units are getting power from the same battery bank. So if the battery shut down, all units stop working. And when there is power from the battery, all units can start working at the same time. But the disadvantage for that is you have to a very big bus bar to support the big current from the battery. So and also the cable should be very strong. Then in this situation, separate battery group is better. But please be careful when you are using the different battery group for different units. Make sure the solar are almost the same, because if, for example, if one unit have 5 kilowatt and another units do not have solar power, one unit have 5 kilowatts from the solar and another have none. So it means that battery for the first unit can be charged. However, the third unit is just 0, so the battery will run out first. When the third unit run out battery, it means that when discharge, only 2 units can discharge. So actually, it's like depends on your application. You can choose connect all battery together as a big battery bank, or you can connect with different inverter with different battery groups. The other advantage for the separate battery connection is that you may add a inverter later, right? As we discussed. For example, one customer buy a system with one 5 kilowatt inverter and with 10 kilowatt hour battery. So the system has been running for 1 year. 1 year later, the customer wants to add another system, same like, for example, 5 kilowatt inverter and 10 kilowatt hour battery. The shame thing is that you cannot mix the new battery and the old battery. The resistors inside is different. So it's then in this situation, you have to separate the batteries. Otherwise, the battery lifetime will be shorter or the capacity is maybe lower than the original one. So then the new one maybe cannot discharge for 10 kilowatt hour or 9 kilowatt hour if the usage is 19%. So in this situation, it's better to connect the battery as a separate group. The last thing of the parallel function is that the cable, since we are using advanced parallel control method, so maybe you have used some other inverters, and it may require you for the AC, if you connect 3 inverters together as parallel, for the AC cable, you have to make sure they are the same length and a lot of requirements. But for our inverter, you just need to make sure the connection is right, like L1 to L to L and the neutral to neutral. Do not short L and the neutral, then it's okay. So it's easy for the parallel connection. This is the function for the parallel part. And then let's go. The next is lithium battery. First, as you can see that our inverter is compatible with most of the brands in the market and support both CAN and RS485 communication. Include this, we have also other benefits can get from the inverter. The first thing is that we can wake up lithium battery when battery shut down. As you know that if the battery shut down, for some inverters, you may need to take a DC source to charge the battery and to wake up the battery. For our inverter, it can wake up the lithium battery when it's shut down. So you do not need to take an extra DC source. Also, that we are able to remote up BMS firmware. But please notice that this is for some brands of the battery, not all. Also, in our server, you can get many detailed information in the system. So you can not only see the hybrid inverter situation in your application, but you can see also other features of the BMS. And I will show you later in our monitor system. You can get more info for the battery. The advantage for that is that customer or the maintenance people or the installer can know that how the system running, is everything good with the battery, is the charge power still very healthy, like it still have the capacity as it's announced. So it's very quite clear for the users, everything. Also, next is that variable working modes. Actually, we have several trainings on the variable working for the working modes for like LXP 12 kilowatt and SNA. Actually, the this working modes, LXP 5 kilowatt working modes, are very similar to the LXP 12 kilowatt. So it have self-consumption mode. Later, I will give a little bit explanation for the working modes. So here we go fast for this part. So we have self-consumption modes. We have first charge and discharge. First charge is like you use AC to charge. AC charge and the first discharge for the area may when the tariff is different. Also that we have charge priority mode, which is you use the solar to charge battery first. Where I think South Africa is a typical application for that because of the load shedding. Once people users have the solar, he wants to use the solar to charge the battery and always keep the battery in a certain capacity. So later, if there is load shedding, there is power from the battery to discharge to take the home loads. This is the working modes, and the next one is advanced APS function. As mentioned, you do not need to buy an ATS or a backup box for the APS function. It's already integrated, and the switch time is typical 10 milliseconds. And also that if you want to have larger EPS loads, you can parallel them to 10 units. So which means the maximum off-grid power is 40 kilowatts when without solar and 50 kilowatts with solar. Also, there are some other advantages like IP16.5 for outdoor use, and also fanless design, which means the inverter runs very quietly and no maintenance needed. And also that it's easy. One man can install the unit. So that's the part of the inverter. Then we can go the monitor system. I will have a very brief introduction for the for our monitor system. Then I will introduce working modes, and meanwhile we can use I have one unit running in our lab, so I can show you when I explain the working modes. I can show you how the system running meanwhile. So actually, the monitor system basic function is like monitoring, remote setting, and also remote update. Actually, that according to different market demands, we also developed some special function, like we have for South Africa market, we have developed a quick charge. So customer can push the button quick charge when they want to charge the battery. This is our monitor system. I think maybe many of you are already very familiar to this. I will show you a little bit later. And this is account. As we mentioned that for our system, we have different types of accounts. So we have administrator, distributor, installer, and end user. The most frequently asked question is where do I get my installer account? So for installers, if you want to get an installer account, please contact your supplier who give you the inverter to ask for, because only the distributor can create installer accounts. And when you become an installer, then you can use your account to create an end user account, or the end user can register themselves. So it's very flexible. So here I want to show you the monitor system and explain the working modes and the settings while we go through the monitor system. Wait a minute. So this is our monitor system. I have one system running here in our lab. This is a LXP5 inverter, and also with the battery with the loads. So you can see now it's a self-consumption mode. But because the solar power is large enough to take the load. Actually, so here we go back to our presentation. So for LXP5, when you get the inverter, if you do not do any settings, it's a self-consumption mode. For self-consumption mode, that's the solar power from the power generation part. If there is solar power, the solar power will first use to take the load. First, the first way is to take the load. So if there is extra power, it will go to the battery, and then at last it will feed into the grid if you enable feed grid export function. If not, then it cannot feed into the grid. So inverter use solar power, and that when the solar is enough. However, when in the midnight or in the morning, the solar is not enough. The battery and the solar will take load first. And so there is no end because the solar and the battery are taking loads. There will be no extra power to feed into grid. There is only one way. In self-consumption mode, the on-grid EOD is very important. For on-grid EOD, it means that it will stop discharge at, for example, if you set 60, it means it will stop discharge when the SOC is lower than 16. It means that below 16 is used for backup. It will only discharge when there is no grid. But when higher than 16 is a self-consumption mode. The benefits for self-consumption is like you have 40% to charge, discharge, charge, discharge. So you can get the like you can use the solar power very well. Let me give an example for you. For example, you have a 2 kilowatt load, and you have 5 kilowatt solar. If you set on-grid EOD 100%, it means once there is solar, it will it can the solar is bigger than the load. It will charge the battery full. But after battery full, since you will not discharge, the other solar power may feed into the grid. But if you disable export function, the solar will be waste. And then a little bit later, the solar became 2 kilowatt, and your load is 3 kilowatt. The solar is lower than the load if you set 100%. So the battery will not discharge. The load can only take the power from the grid. So that means if you set a very high EOD, it means maybe the solar will be waste because you will never discharge from the battery. If you never discharge, it means when there is grid, it means you have no chance to charge because it's always 100%. So actually, this is a level for the 16. For example, if you set 16%, it means 16% is for backup. 40% is for self-consumption. When you use this buffer to charge, discharge, to get benefit from the solar. And if you set very low, if you set the on-grid EOD, for example, 20%, which means maybe you haven't like reserve enough power for load shedding. But if you set too high, for example, 19% or 100%, it means that there is no self-consumption way. It's only 100% for backup. So you have to get a balance. How much power you have to reserve for the load shedding. As I mentioned that for the on-grid EOD setting is very important in self-consumption mode. And when you get the inverter from the supplier, all the settings default are disabled. But maybe after a while, some people or your family change the setting. If you want to go back to self-consumption mode, you have to disable charge first, AC charge, and force discharge. So after you disable them all, the units go back to self-consumption mode. So we can go to see this inverter. We can go to maintenance. And we click read. So we go to charge and discharge setting. You can see AC charge is here. So AC charge is disabled. Charge priority is disabled. And the force discharge is enabled. So all of them are disabled. It means that now they are in self-consumption mode. Let's see, also find where is the on-grid EOD. So I think it's here. This is on-grid cutoff SOC. When you set 10%, it means that the battery will discharge to 10%. We can set a little bit higher, for example, 90. Maybe the signal is not so good. So it go back to okay, set successfully. So if you set here 80%, it means that when there is grid, the battery will discharge to 80% and reserve the 80% of battery capacity for load shedding. And we can go to the first page. You can see that the system is taking load, so there is enough solar, and let's see if we can try to take off some loads, and because the battery is already 100%, so it will not charge the battery if there is extra power. We can turn, if the solar is not enough, then in self-consumption mode, it will discharge until the EOD. So we can maybe turn off the PV, so battery will discharge to take load. But let me, wait a minute, I will ask my colleague to support me to do some change because the devices are in the lab. Maybe here we can test some other function like force discharge. Let's wait our engineer to turn off the PV, so we can see that when there is solar in self-consumption mode, the solar will take the load. When there is no solar or solar is not enough, the battery will discharge to take the load. Okay, they turn off the PV. Let's see. Well, if you have any questions, you can post in the chat. So it's discharged from the battery, and the discharge limitation is 100 amps. But it's only okay. We need to. Okay, so you can see the battery discharge and go up until to take the load completely. So you can see that from the monitoring, we just show when there is solar will take load, and when there is no solar, the battery will discharge to take the load. So this is the self-consumption mode. I think it will take a little bit time to discharge the battery to 80% to stop discharge. But we will show later once they finish discharge. So the inverter is using the battery to take load. Meanwhile, we can do give explanation for the other working modes. So The next is charge first. Charge first means that, as I mentioned, if you have solar, for self-consumption mode, if there is solar will be used to take load and to charge battery, and then at last feed into the grid. So the difference is the first where the solar goes. In charge first mode, the solar will use to charge the battery first. So, and if there is extra power, the solar power will use to take the load. So if the solar is not enough, it will use the grid to take the gather. That is also the difference. For example, in self-consumption mode, there is 4 kilowatt from the solar and 5 kilowatt from the 5 kilowatt for the load. So the extra 1 kilowatt will be from the battery, because self-consumption mode is to use the grid as less as it can. So solar and the battery will take load. But in charge first mode, if solar is not enough, solar and the grid will take the load. The battery will not discharge during the charge first time. So we can see for the charge first mode is here. This is charge first. You have to, if you want to, you always use your solar to charge your battery first. You have to first enable charge first, and then choose when you want to charge first, and also that how much power you want to go to. For example, I only want to, because it's very similar idea about with self-consumption on grid DOD. For example, if I always want to use 80% for reserve for the load shedding, so I set 80% charge priority, because the solar, when there is solar, it will charge the battery first. After it charged to 80%, it will not charge first. It will go to take the load. So that's the purpose for charge priority charge level. It means that when is the stop charge first. For example, if you set 18%, then the solar will charge the battery to 80%, and then the solar will first use to take load, not to charge the battery. So that is the charge priority charge level means. Of course, and you have to set the time when you want to charge the battery first. If you want to always to charge the battery first, you can choose the whole day as here. And this is the AC charge. AC charge means you use AC to charge the battery. You can set the AC charge rate, the AC battery charge level, which this is very similar to this one. For this one is you use solar power to charge battery when the stop level, and for this when the AC charge stop level. So if I want to use AC to charge the battery to 80%, then you can set 80 here. And also similar to charge first, you have to set the AC charge time, the start time and the end time. For the default, we will set the whole day. So if the battery is low, we will, once there is grid, we will use the AC to charge the battery to a certain level. So actually, this is also a very tricky thing, is that if you set too high, you will maybe waste your solar. Only that, for example, if you install the system without solar, so we suggest you then you set 100% here, which means once you have grid, you will charge the battery full. So later, if you have load shedding, the battery have get the already very high battery level. But if you install the solar in your home, and we won't suggest you to set 100. Because if you already set battery to full, use AC to charge it to full, it means that your battery, your solar energy may be waste. So you have to find a point where how much power you want to reserve, you want to use AC to charge. Okay, so it's still discharging. Also, you can see that for here, when you click here, you can get the charge and the discharge limit for the battery. It's very easy to find. If you find any charge current, why it's so small, and similar situation, if you want to analyze, you can click battery here. So it will show charge and discharge limit. Also, we have a system running in our showroom and it's in off-grid mode. Please let me know if you have any questions for the working modes. I think I will stop here. So if you have any questions, you can put in the group if you want to ask more about the working modes. And here, I'd like also to show you the parallel system I mentioned. Okay, this is a South Africa installation called Start Line. The station name is Start Line, and we installed the system in 2019. So you can see this is a very typical three-phase parallel. The system shows three-phase loads and voltage and frequency here. You can see inverter list here. So totally, there are 8 units in the system, and for R phase, they always have bigger loads. So they installed 1, 2, 3, 4. They installed 4 inverters in the R phase, and installed 2 inverters in S phase and 2 inverters in the T phase. So for each phase, they have different inverters. And also that for this installation, they share the battery. So the battery voltage and the battery SOC is same. Because as in South Africa, I suppose, I guess they are, let's see why it's not discharged. And I think they're setting like charge priority. Let's see his settings to understand why it's running like that. Okay, and okay, we can check the master inverter setting. So you can see that for this station is absolutely for the backup. AC charge is enabled, and the AC charge level 100%, and the time is from the morning to the evening. That's why you can see since he enabled the AC charge, but now the battery is full. So the battery will not discharge when you enable AC charge. The solar power is used to take the load. When the load is not enough, it will use the AC to take the load. But the battery will always keep 100% in case there is any load shedding. So this is a typical three-phase installation, and they want to always back up the battery as 100%. And so in the bottom, you can see the energy generation. Like in 2023, for each month generation, solar generation. And we go to total, so we can see from 2019, the system has been running very well for already 5 years. This is a 3-phase parallel and share the battery. Also, we have another installation in UK. So this is a different application. In this house, the customer has utility, has grid, but he don't want to use the grid. He wants like power independence. So he installed 5 inverters in his house. Actually, you can see the SOC is a little bit different because they connect the battery separately, and this is a single phase parallel. So there is all in the same phase or the units, and also it's already running like 5 years. It was installed in 2019. So this is a single phase parallel and with self-consumption mode. So they do not want to use the utility. Okay, that's all I want to share. Please let me know if you have any questions. Let's see if we have any questions in the group. Okay, so you want to check the start line, right? So here is the setting. Battery shared is enabled. So all the inverters are share the same battery, a big battery group. No, for the start line, I just show is a shared battery. So the battery SOC and the voltage are same. You can see here, this is a start line. The battery is shared, is enabled, and they connect to a big battery bank. And you can see here, the battery voltage and the battery SOC are exactly the same. And we have another installation I just showed is in UK. So they connect the battery separately. This is a station. You can see the SOC is different. The voltage is different because all inverters use their own battery. We can check the setting here. So you can see here, battery shared is disabled. Each inverter has its own battery group. So the battery voltage and the battery SOC are a little bit different. So Jim Michael, we didn't talk about AC coupled. We are just explain the parallel system, battery shared and separate battery. So Werner said, but not the upload shading, that's reconnection time for TVS. Also for the, if it's from the on-grade to off-grade, if you think I'm not sure how long it is. You can, there is a seamless switch here. Please check your settings. Seamless switch. If your switch time is a little bit longer, you can check if you enabled seamless EPS switch and check. If you still have questions, you can send your questions to our email or local group. We shared in the last page here. So this is charge first and AC charge, and here is our support with, you can contact our partners and colleagues for technical support. They are connected in parallel at the EPS side. So we can, because for the EPS, for the grid it's easy. Every inverter connect to the grid, and all the for the EPS, they are connecting EPS together to make a battery like big power supply. So it's like the EPS side. Because you see that for this inverter, they do not have AC, they do not have grid. So they disconnect the grid from his home. This is a UK installation. There is no AC. So he just connect the 5 units EPS together. So for example, for one UPS inverter, you have 4 kilowatt when there is no sun, the 4 kilowatt output. So if you connect 5 units, you get 20.
Okay, that's one. There.
Okay, let's see if you have more questions. If not, we will end the webinar. Okay, and I think Miamia has left our contact way in the group. If you have any questions, please send email to us or join our group. Then we can reply you as soon as we can. Okay, thank you everybody. See you next time.